Look at something red, a stop sign, a piece of clothing, an apple sitting on your desk. Really look at it. Focus on the redness. It feels completely undeniable, doesn't it? It feels like the redness is a physical, intrinsic property of the object itself, like the universe took a paintbrush and physically coated that apple in red paint. We walk through our entire lives trusting this perception. We trust our eyes. We believe we are looking out a clear window into reality. I have some profoundly bad news for you. If you could step outside of your own skull, if you could somehow look at the universe as it physically, mathematically exists, without the filter of human biology, there is no red, there is no blue, there is no bright, vibrant green. The universe is a completely, terrifyingly colorless void. Today we are looking at Feynman Lectures Vol I, chapters 35 and 36. We are going to find out why your eyes are lying to you, how your brain completely hallucinates reality in real time, and why one of your favorite colors is a literal software glitch. To understand why color is a lie, we have to start with the physics. We have to understand what light actually is. Imagine you are floating in the middle of a vast, dark ocean. There are waves constantly rolling past you. Some waves are massive, the size of skyscrapers, gently lifting you up and down every few minutes. Some waves are tiny, rapid, violent little ripples splashing against your face. The universe is filled with an ocean exactly like this, but it is made of electromagnetic radiation. Light is just a wave in the electromagnetic field. It is exactly the exact same physical phenomenon as the X-rays that see through your bones, the microwaves that heat up your leftovers, and the radio waves that carry Spotify to your phone. The only difference between a radio wave and the light hitting your eye right now is the size of the wave. The distance from one peak of the wave to the next is called the wavelength. Radio waves are gargantuan. A single wave can be miles long. Microwaves are about the size of a butterfly. But nestled dead in the center of this infinite ocean is a tiny, microscopic sliver of waves. We are talking about waves ranging from roughly 400 nanometers to 700 nanometers long. A nanometer is 1/billionth of a meter. When a wave that is 700 nanometers long bounces off an apple and flies through the air, it is completely invisible and totally colorless. It is just a vibrating mathematical distortion in a magnetic field. It carries energy, it carries momentum, but it does not carry paint. It does not carry red. The universe doesn't deal in colors. It deals in frequencies. It deals in math. So where does the red come from? Before the light reaches your eye, we have to talk about what happens when it hits the object. And this brings us to one of the most counterintuitive facts in all of physics. Let's look at a bright green leaf on a tree. The sun is essentially a massive nuclear fusion reactor bombarding the earth with white light. White light is just a chaotic mixture of all the wavelengths crammed together. Red waves, blue waves, yellow waves, green waves, all hitting the leaf at the same time. When this ocean of mixed radiation hits the physical atoms of the leaf, a violent chemical interaction happens. The leaf is packed with a molecule called chlorophyll. Chlorophyll acts like a sponge for specific wavelengths. It perfectly absorbs the long 700 nanometer waves, what we will eventually call red. And it absorbs the short 400 nanometer waves, what we will call blue. It eats that energy and uses it to build sugar. But the chlorophyll cannot absorb the medium-sized waves, the ones around 530 nanometers. They don't fit into the chemical lock. So the leaf rejects them. It spits them back out. It reflects them away. Think about the sheer mind-bending irony of this. We call the leaf green, but green is the only wavelength of light that the leaf explicitly rejects. The leaf absorbs and holds on to the red and the blue. From a purely physical standpoint, that leaf is every single color in the universe except green. The color you perceive an object to be is entirely based on the garbage radiation that the object throws away. You are looking at the universe's leftovers. So the leaf rejects the 530 nanometer wave. That invisible, colorless, vibrating magnetic field flies through the air at 186,000 miles per second, enters the pupil of your eye, and crashes into the back wall of your eyeball. This brings us to the biology of Feynman Lectures, Chapter 36, Mechanisms of Seeing. Feynman points out something incredible about the back of your eye, the retina. The retina is not just a sensor connected to a wire. Biologically and evolutionarily, the retina is literally a piece of your brain that was pushed outward, out of your skull, during fetal development, so it could look at the world. Your eye is a meat camera, and the film is alive. On this living film, you have millions of microscopic light-sensitive antennas. We categorize them into two main groups, rods and cones. The rods are the heavy lifters for survival. They are incredibly sensitive to any light at all, but they do not care about wavelengths. They just detect light or no light. They are your night vision goggles. If you walk into a dark forest at midnight, your rods take over, painting the world in grainy shades of black, white, and gray. But tucked right in the very center of your retina, in a tiny pit called the fovea, are the cones. Humans typically have three types of cones. This is the foundation of the young Helmholtz theory of color vision, which Feynman details. The L cones. These antennas are physically tuned to vibrate when hit by long waves, around 700 nanometers. The M cones. These vibrate when hit by medium waves, around 530 nanometers. The S cones. These vibrate when hit by short waves, around 420 nanometers. When the rejected 530 nanometer wave from the leaf hits your retina, it perfectly matches the tuning of your M cones. The cone undergoes a violent chemical change, snapping a protein in half, which fires an electrical impulse. That electrical impulse travels down the optic nerve, plunging into the pitch black, silent, squishy meat of your brain's visual cortex. At this exact moment, physics ends and hallucination begins. Your brain is locked in a dark vault. It has no windows. It has no idea what a tree is, what the sun is, or what electromagnetic radiation is. All it receives is a chaotic storm of Morse code, beeps and boops of electricity coming from the optic nerve. Your brain has to keep you alive. It has to help you find ripe fruit in a dense jungle. It says, I need a way to instantly, intuitively tell the difference between a 700 nanometer signal, a ripe apple, and a 530 nanometer signal, poisonous leaves. How do I display this data to the user? The brain's solution is genius. It hallucinates a vibrant, glowing sensation. It invents a graphical user interface. When the long wave signal comes in, your brain projects the sensation of red. When the medium wave signal comes in, your brain projects green. Color is not a physical property of the world. It is a biological translation software. Think of your computer desktop. When you drag a file into the trash can icon, there isn't actually a tiny aluminum trash can inside the microchips. It is just binary code, ones and zeros, voltages flipping back and forth. The picture of the trash can was invented by a programmer to make the complex math easy for you to interact with. Red is the trash can icon. It is an evolutionary shorthand. And because color is just software, we can prove it has glitches. We can break the code. Feynman talks extensively about color mixing and how the brain interpolates data. If you see a 700 nanometer wave, your brain renders red. If you see a 400 nanometer wave, your brain renders violet. If you see a wave right in the middle, around 550 nanometers, your brain renders green or yellow. But what happens if a red wave, 700 nanometers, and a violet wave, 400 nanometers, enter your eye at the exact same time, but there is absolutely no green wave in the middle? Your brain completely panics. It looks at the data and says, wait, I am receiving signals from the absolute opposite, extreme ends of the spectrum simultaneously. But my software is programmed to map colors linearly, like a rainbow. There is no single wavelength of light that matches this combination. What do I do? The brain is trapped. So it does what any desperate software program does. It patches the bug by making something completely fake up. It invents magenta. If you look at light split by a prism or a natural rainbow in the sky, you will see red, orange, yellow, green, blue, indigo, and violet. You will never see magenta in a rainbow. Magenta does not exist on the electromagnetic spectrum. It has no physical wavelength. It is a biological error code. It is a placeholder your brain invented to bridge the gap between two opposing mathematical signals. Every time you look at a magenta flower or a magenta neon sign, you are staring directly at a crack in your own biological programming. Why does understanding this matter? Why ruin the magic of a beautiful world with the cold, hard math of Feynman's physics? Because we walk through our lives feeling very small and feeling very confident that we see reality exactly as it is. We think we are just passive observers in a universe that doesn't care about us. But physics shows us that we are completely, utterly isolated from true reality. We are locked inside a dark bone box. We never see the actual world. We only see the translated, hallucinated, color-coded map that our brain projects onto the inside of our skull. When you sit on a beach and watch a sunset, and you see the sky burst into fiery oranges, deep purples, and vibrant pinks, the universe isn't actually doing that. The universe is just throwing a chaotic soup of cold, invisible, vibrating magnetic fields at your face. The universe provides the math, but you provide the magic. The beauty of the sunset isn't out there over the ocean. It is happening entirely inside you. You are taking the cold, dead mechanics of electromagnetic radiation and painting it with the most profound, breathtaking sensations imaginable. You are not a passive observer of a colorful world. You are the architect of its beauty. You are painting the universe in real time every single time you open your eyes.